Hi, and welcome back to the course. Let's understand highly available or HA architecture in this video. Remember, we saw earlier that in Hadoop 1.x, name node was a single point of failure. If the name node failed, then the entire cluster was lost. There was no way to reconstruct the cluster till the time the name node was restarted manually, and as you can imagine, that takes time. This is where Hadoop 2.0 comes to solve this problem. In Hadoop 2.0, the HDFS high availability feature addresses the above problem, providing an option to run two name nodes in the same cluster in an active or passive configuration with a hot standby. This allows fast failover to a new name node for any machine crashes or administrator initiated failover for any planned maintenance activities. Here, active name node handles all client operations on the cluster, whereas standby name node has similar data as the active name. If the active name node fails, then passive name node takes all the responsibility of the active node and the cluster continues to work. Let's see how this is achieved in a bit more detail. There can only be a single name node active at a time. If there is a scenario where each name node is active, then the data might be corrupted. We call this split brain scenario, where the cluster is divided into smaller clusters. This situation can be avoided with a process that's called as fencing. Fencing ensures that only one name node remains active at a particular time. We'll discuss what is fencing later in the course. For high availability, the name node must be in sync with the standby name node. It should share its latest state continuously with a secondary name node, but how does it happen? This happens with the help of a group of nodes or daemons known as the journal nodes. Ideally, there should be at least three journal nodes. For n journal nodes, the cluster can tolerate n minus 1 by 2 failures and still function properly. So for three journal nodes, the system can tolerate 3 minus 1 divided by 2, which is 1 failure. When active name node performs any modification or operation, it writes the changes to the journal nodes. The standby name node continuously reads the current updates on the journal nodes and updates its namespace. In case a failure occurs, the standby name node makes sure that it has read all the updates from the journal nodes before promoting itself to the active name. This is how high availability is achieved. The cluster functions as normal even in case of a name node failure. Alright, now let's see what is failover and fencing in the next video. I'll see you there. Thank you.